Hello students, hope you are doing well. Today we will be finding the rate of convergence for regular-Falsi method. Okay, so I will suggest you to take out a pen and paper. We will be doing some derivations. It will be little lengthy, so you need to solve it along with me. Okay, so let's see. What do you mean by rate of convergence? This is basically we want to see the error in the current step, how the error in the current step is depending on the error in the previous step. Okay, suppose I am standing at n plus 1 step. Okay, n plus 1 step. That means I want to see what is the relation between the error in the n plus 1 step and the previous step, that is the error in the nth step. Okay, so let's see. So here my starting point is we have considered a beta 2 will be my root. So if beta is root, then means f beta will be 0, right? So rate of convergence means we need to find the value of m. What is m? See, I told you the error between the two steps. Like how the error in the current step is depending on the error in the previous step. And this is a generalized equation. Okay, generalized. This is valid for every method. This is a constant and this is also a constant. Okay, if m is 1, then it is linearly varying. If it is 2, then the order is 2, like that way. We need to find out this m. Okay, so we need to find out the error, relation between the errors of successive two successive steps. Fine. So the starting point is to consider root. So from from Regular-Falsi method, we know this. To find a new value of c, we can apply this much, this formula. What I have done is I can write this equation like this way. Okay, just separating the terms. Fine. Now let me make it more generalized. So this was our curve, right? So this is A point, this is your B point. And I told you in some books you will find instead of it they will write x0. Okay, and some book it will write x1 and the corresponding functions will be fx1 and fx0. Fine. And the new point they will write instead of c they can write x2. Okay. So considering that, I can write a generalized expression. Okay, so here you can write it, you can map with x2. This is your x1, this is your x2. That means basically this is your a, this is your b, this is your c. Fine. This is the, you can write it from this equation. Now what is the error in one step? So the error in the n minus 1 step is this, in the n step is this, and n plus 1 is this, the error. This much is the error. Epsilon n plus 1, epsilon n minus 1. Here, suppose this is a beta, this is your root, this is your destination, that means this is your college. In our analogy, this is your college. You want to reach college. But instead of reaching college, you move little forward. And you reached, say, Science City, or Boishaki, or Dhapa, whatever may be. So you move little further, you have crossed your college. Okay, then the relation will be like this. So you move the extra distance will be my error. Okay, and it can be both negative or positive also, but I have chosen to write in this way. Fine. Now in this expression xn plus 1, I can write this one, and instead of xn I can write this one, and instead of xn minus 1 I can write this one. So I have written this. Okay. Now if you simplify this, you will get this one. Now the thing is, this will cancel out first of all. This will cancel out. Now see here, a term comes at f beta plus epsilon n. Okay. I told you whenever these type of function terms will come in your derivation, what you need to do, you need to expand it by Taylor's theorem. Fine. So I can write this one as f beta into epsilon n first order derivative, second order derivative, and this is your epsilon n square by 2. And there will be other terms also, but in this case I am neglecting the higher order terms. Remember, I am neglecting the higher order terms. Okay, and this will remain as it is. Similarly, I have expanded this one. Similarly, I have expanded this one. Okay, only see the suffix will change. Instead of n, here it will be n minus 1. And other terms, remember, I have neglected. Fine. Now, what is a beta? That means the function value at the point beta. This is my root. So if beta is my root, that means a beta should be 0. A beta should be 0. So this will vanish. And this will cancel out. This 2 will cancel out. And what I have done here is, I have taken epsilon n common, and I have basically taken epsilon n and f dash beta common. So common, and I have written this one here, and only since I have taken f dash beta common, so this will go down here to nullify it, to adjust it. In this way I have written this one also. This f beta is cancelled out, and if you map with this and this, you will get if you take f dash common, you will get this. If you take f double dash common, you will get this. Okay. Now what you can do is, this is basically you can map with a square minus b square formula. So it can be written as a minus b a plus b. So a minus b, and this also will be a minus b, right? And this is also a minus b. So this whole 3 terms will cancel out. Only a plus b term will remain. That means epsilon n plus n minus 1 will remain. Okay. And if you take f dash beta common, this will also cancel out. Okay. So after this we will get this one. Fine. So here I have written this p. What is p? P I have written is f double dash beta by f dash beta by 2. So if you take f dash beta common from here, so one f dash beta will come here, and if you consider 2, so this part, so that means this part I have written as p. Okay, p. Okay, then what you can do is, this denominator I can write it in this way, inverse minus 1. Now just expand this one by binomial theorem. Fine. So what will come? This minus 1 will be inside, will come inside, and there will be other terms also, right? If you can see, if you can go through with the binomial theorem, then you can write this neglecting the higher order terms. There will be other terms also, okay, but I am neglecting it since this epsilon n will be very, very small. Okay, then you can multiply this 2, and you will get this whole term. Then what you can do is, this term and this product will be same, and it will be opposite, so this will cancel out. Only this part will remain. Only this term will remain, and I have neglected this whole term. Why? This is product of 2 errors, right? So it will be very, very less. This one also, and it is the product in the same step, right? In the n step. So I have neglected this whole term. So we will be reaching at this point. Okay. Then if you multiply this epsilon n, you will, and if you simplify, you will get this. Okay. Now what you can do is, we know, I've told you that the error in the n plus 1 step I can write in this way. Okay. So instead of epsilon n plus 1, I can put this value here, and what I can do is, epsilon n can be written like this, but don't put this here. What we will do here, we will take the epsilon n minus 1 from here and we will replace this epsilon n minus 1. Okay, so I have written this a will come down here, and this power will be, if I shift this power here, so it will be 1 by m, right? And a, if I put it in, it will be a inverse, and it will be a inverse. If I adjust with the powers, it will be a inverse 1 by m. Fine, so you will get this. So replace this one by this, keep this one as it is, and replace this epsilon minus 1 by this one. Okay, now what we will do, if you just adjust this, you need to compare the power of this error. Okay, so if you compare this, just compare this part, only this part, epsilon n part, then it is m is equal to 1 plus m. So I can write m equal to 1 plus m, and this part, this one is basically 1, right? This part, there is no term here. There is no term. This term is not here, right? This term is not here. Basically, it is 1. So if you do it, you will get, first of all, you need to compare this power, and this power. So if you compare this, you will reach at this point. And if you solve for m, you will get 1.618. So this is your rate of convergence for regular-Falsi method. You need to remember this. They may ask in the exam, they may ask as an objective question. Okay, and your a will be this. That means this constant will be related with p. What is p? P is this one. Fine. So you need to know this. Even you skip this derivation, you need to remember this one. Okay. So I will suggest you to go through this once again. Repeat this video. Okay. Replay this video and do it on a page. Okay, by yourself. Then you will be only able to understand, because there will be some intermediate steps. This process will little bit lengthy. Okay, so I will suggest you to do it on your own. Okay, following my steps. Okay, so you need to remember this one. In this much you need to know about regular-Falsi method. Okay, in the next class I will make a video for some queries. Okay, some students have some queries related to the previous videos, so I will discuss that, and I will discuss a new method, second method. The second method is absolutely same with this. The second method is basically regular-Falsi method. One change will be that instead of FC, if you can see my previous video, there are in every step, in every iteration, we have calculated the FC and we have checked the sign, and depending on the sign we have changed the interval. But for second method, you need not to find the FC. Okay, you need not to check the sign. The process will be same. Okay, the whole process will be the same. You need not to check the sign. Then what will be your new range? Remember, in that case, the new A will be your B, the new A will be your B, previous B, and your B will be the C which you have calculated in the previous step. Okay, so you have started with A and B. In the next step, what will do? Your B will be your A, and this A will be your B, and your C will be your B. That means I am telling you have started with AB. In the next step, the B will be your A, the A will be your B, and this C you have calculated in the table, this C will be your B. Fine. In that way, you need to we will proceed. The process will remain the same. The problem is the second method. The method may not converge. It may diverge also. So, but in this case, regular-Falsi, it is more allowing us that it will be, we will more sure that it will be converging. Fine. So you need to see the difference between these two methods, secant method and Regular-Falsi method. Only you need not to calculate the FC, that means you need not to check the sign. Okay. So in this you will not, you can change this, I have said this is for secant method. Secant method. The other whole process will remain the same. Okay. So this much for today. Okay. Stay safe. Thank you.